Unmute, share screen. All right, so now we're back to Zooming and playing. Good, I think somebody joined, that's fine. All right, I think I got another one or two of these, and then I want to talk about another thing. All right, let's see what we got here. Hey, what's the greatest common divisor of 9 and 30? And I'll talk about it after this. There's another little mathematical thing to do. And this is really about as deep as the math is ever going to get. Don't panic. All right. So the point is 9 is 3 times 3, and this is 3 times 10. So the divisor is 3. There's nothing larger. Now, let me point out the algorithm for this. If you want to find the largest common divisor, and this is real important for RSA, which we'll get to. So 9 is 3 times 3. 30 is 3 times 10. But 10 is not a prime number. So the way to do this right is you have to factor things down to their prime factors. So this is 3 times 2 times 5. And those are all prime numbers because they're not composed by multiplying smaller numbers together. That is the limit to how you've decomposed it. So 3 times 3 and 3 times 2 times 5, they have 1 3 in common. So the largest common divisor is 3. You can divide them both by 3 and it's even, and there's nothing large you can divide them by. I can't divide them by 6, can't divide them by 5 or 9 or anything. That's what the greatest common divisor is. And this will come back because you don't actually need prime numbers for RSA. What you need are relatively prime numbers, which means the two numbers have no common divisor other than 1. We'll get there. Anyway, that's what a greatest common divisor is. The largest number you can divide them both by evenly. So let's try another one of these. All right, largest common divisor of 8 and 32. All right, that's true. If you hit the wrong one, you're just toast. There's no undo. All right, that's 8 because 32 is 8 times 4. So you can divide them both by 8. Some people are given 4. 4 is a common divisor, but it's not the largest divisor. 2, 4, and 8 are both common divisors. 8 is the largest one. All right, I don't know if I got any more of these or not. I don't. All right, so there's the winners, Joe, Swede, and Patriots. All right, and I got some more of this stuff. All right, so these are the binary games you've seen before. They're in here as extra credit projects. And I'm going to add some more for that stuff we just did, modular arithmetic and greatest common divisor, just so you get practice at these things. And XOR, that's the third one I plan to add here, and I think that's about it as far as this kind of mathematics. But first, you got to know your binary. Everything is all binary in computers. So let me bring this down. If you've been taking my classes, you've seen this before, but you got to remember it. So here's the game. Should be, there we are. All right. So in base 10, 147 is 100 and 4 tens and 7. The placement of the numbers matters. The one on the right is the ones. The one on the left, next one is tens. The next one is hundreds. And that's 10 to the 0, 10 to the 1, and 10 to the 2 is what those places stand for. That's base 10, which we've all gotten used to using, although it is very strange and unnatural when you first learn it. You may not remember second grade, but I do. Base 2 is the same thing taken to binary. So you have only 2 numbers, 0 and 1, so you call it base 2. So 1, 1 means a 1, and this is the number of 2s. So 1, 1 is 3. And this number is 5. The one on the right is the number of 1s, the next one is the number of 2s, and the one on the left is the number of 4s. That's base 2. And so if you count to 7, it looks like this. 1, 1, 1 is 7, 1, 1, 0 is 6. You might notice that even numbers are even in both systems. All even numbers end in 0. All odd numbers end in 1. You can read it the same way you would. So 4 bits make a nibble. You have the 1s, 2s, 4s, and 8s. That's half of a byte, and that's as far as we're going in this lesson. So you can count to 15 with nibbles. 1111 is 15. 1110 is the even number below it. That's 14. 1010 is 10. One I've memorized, quite handy. 1100 is 12. You learn to spot these, and you have to learn to switch them back and forth from binary to decimal to do this stuff. You get used to it. So that's the game, and you can easily create that chart on a scrap of paper if you need it. And I have a Kahoot for this stuff. So I'm going to leave this site, and here we are. Nibbles. I'll see how people do on your nibbles. My Kahoot is loading. It seems to be remembering this stuff. That's good. Randomized order of answers. That's the only one I really care about. Okay. Okay. 308, 331. Someone on the stream told me to read out the number. 308, 331. Although I think with the Zoom, it's good. They told me there's no delay on Zoom, but there's a 30-second delay when I'm broadcasting through the City College streaming service, which really puts the remote viewers at a Kahoot disadvantage. You do what you can. Okay, I'll wait another few seconds. Yeah, Hubcap got an exclamation point this time. All right. So, 8 questions. Okay. Okay, what's 0B is how you indicate binary in Python. I decided to stick to that. So what is that number in base 10? 0011. Okay, it's 3. 3 is the most popular answer. It's not 11. This is 11 in base 10. 10 plus 1. This is 2 plus 1. So, all right. Let's try another. That 1111, what is that in base 10? The 0B just means it's in binary. All right, I'm not going to go any further than this because you're not getting them 100% right. So this is the right place to start. You got to learn your nibbles before you go forward. Okay, this is 8 plus 4 plus 2 plus 1, that's 15. 7 is 111. 4 plus 2 plus 1. It would be 0111. So 15 is right. How about this one? 1010. Seemed like it didn't wait as long. Anyway, maybe it quits when everybody answers. Anyway, that's 10. Like I say, 10 is 10 because it's 8 plus 2. This is the number of 8s. This is the number of 4s, 2, and 1. I'm just sort of disturbed by a lot of people giving other answers. But this is, you just started the right. Oh, trying to be fast. I hope so. Yes. All right. All right. So that's a good point. It might be rushing to get the points. What's 7 in base 2? I think it is. It sounds lousy enough. I think they made their own music, you know. Sounds good at first, like most video games. After you've heard it 1,000 times, it's not as much fun. Anyway, that's 111 is correct. Good, we're getting there. All right. How about 6? All right. 110 is correct. A lot of other numbers there. It's even, so it has to end in 0. That's all you need to look at. All the rest of these are odd numbers ending in 1. Anyway. All right. Is there another one? Another couple of these. Okay, 14 in base 2. Okay, that's the most popular answer, 1110, because it's 1 less than 15. This is 15, and that's 1 less. All right. How about that one? 1001. After a while, you get your nibbles memorized. Okay, it's 9. 8 plus 1. All right. How about 12? That's the last one. All right. I think they do have more than one music. Yeah, they probably paid somebody to write this music. So that's it. 14 is 1100. All right. All right. So there's the winners. Ward and Cam. I've seen them before. Cam and Swede, they're all repeat winners. And Swede. All right. I think that's enough of this for today. We'll have more of these. Every class will have at least one of these simple math things so you get some practice in them. Any questions about anything? You can go to the lab and do your homework if you want to. Nothing is due for several weeks. No class next week, I think. 9/4 is some kind of holiday. So if you won, you're going to have to tell me your real name or you aren't getting your points. So come let me know. And let me stop the sharing, which is stop and stop.